This video will cover section 8.5, part 2. And last time on the part 1 video, we left on this problem. We actually solved the whole problem. And now what we're going to do is move on to a determinant of a 3 by 3 matrix. So before we get into the formula, we're going to derive it. And so what I'm going to do here is we have some products already, and each product represents the multiplication of certain elements of the matrix. So what I'm going to do for convenience, I'm going to rearrange them, and I'm going to take the ones containing A1 first. So I will have A1, B2, C3 minus, and for this one here, I'm going to rewrite it in, just to follow an alphabetical order, so A, B, C. A1, B3, C2. Now, after that, I'm going to take the ones containing A sub 2, so it will be this one here and this one here. So I will have minus, and I'm going to take this one first. So negative A sub 2, B sub 1, C sub 3. So again, I'm rearranging them in alphabetical order. Then I will take this one, and that will be plus A sub 2, B sub 3, C sub 1. Now I'm going to take the two terms that are left, which will be this one and this one here. And first, I'm going to take the one with the positive sign. So plus A sub 3, B sub 1, and C sub 2. And lastly, that one. So negative A sub 3, B sub 2, and C sub 1. Now, what I'm going to do is factor out the term they have in common, and you can see here that they both have A sub 1. So I'm going to factor out A sub 1. From here, I will get, from this term, if I factor A sub 1, I will get B sub 2, C sub 3. And if I factor A sub 1 from here, I will get minus B sub 3, C sub 2. Now, from the next two terms, I'm going to factor out A sub 2, and actually I will factor out negative A sub 2. So that would be minus A sub 2. If I factor that out from here, I will get B sub 1, C sub 3. And if I factor negative A sub 2 from here, I will get minus B sub 3, C sub 1. Now, for the last two terms, I'm going to factor out A sub 3, positive. So plus A sub 3. And if I factor that out from here, I will get B sub 1, C sub 2. If I factor A sub 3 from here, I will get minus B sub 2, C sub 1. Now, what we have here is actually going to be the determinant that you will see coming from here. So that will be B sub 2, B sub 3, C sub 2, and C sub 3. And so I know that is the determinant because if I do follow the formula, it will be the product of B sub 2 B times C sub 3, which I have here, and then minus the product of B sub 3 times C sub 2, and so that is this product here. So in a similar way, we could say that the product that we see here, it actually represents the determinant of order 2 or a 2 by 2 determinant from here. So it will be B sub 1, B sub 3, C sub 1, and C sub 3. And just to confirm, remember, the determinant of a 2 by 2 is obtained by multiplying those two terms. So that's what we have here, minus this product, and that's what we have here. Now for the last one, we will have A sub 3 times, and here we have another determinant, another 2 by 2 determinant. And so that is the one that will come from here. B sub 1, B sub 2, C sub 1, C sub 2. And that determinant will be obtained by multiplying B sub 1 times C sub 2, that's what we have here, and then subtracting B sub 2 times C sub 1. And so that would be the formula for a 3 by 3 matrix to find the determinant of it. The formula, you can see it here. So the numbers that we have here, they're going to be called the numerical factors. And the 2 by 2 determinants, we will refer to those as the second order determinants. And now you can see, let's go over the definition. So each of the three terms in the definition, so this is my first term, second term, and third term. So each of the three terms, they will contain two things, a numerical factor, which are here, and a second order determinant, which are the ones here being pointed at by the arrows. And the numerical factor in each term is an element from the first column of the matrix. So in this case, they're limiting ourselves to the elements on the first column. I want to tell you one thing. We don't have to do that. We could select either the elements of the first column or we could select the elements of the second column, or we could select the elements of the third column, or we could even select the elements of the first row as our numerical factors, or our second row, or even our third row. And that will just be decided. You will decide that you will think about what is more convenient to you, and I will explain that in the following examples. Now, there is some order of signs, and here we see that we started with a positive sign, and then we have a negative sign, and then a positive sign for our cofactors, our numerical factors. Now, one thing you can do here to keep the order of those factors, if you select something other than the first column, you could just keep this order of signs. So you start here, the element of first column, first row will always be positive, and then the signs will be alternating. So this will be negative, this will be positive. Now, if you decide to choose your first column, you start with the first element being positive, and then negative, and then positive. So here you can complete the signs as long as you are always alternating the signs. So this will be positive, negative, negative, positive. There is a kind of long explanation on the book. So what it means is that if this element is in the first column, first row, you will actually add those two numbers, 1 plus 1, and you will consider this, negative 1 to the power 1 plus 1. And so that will be negative 1 to the power 2, which is positive 1. Now, if we look at this one, for example, that element will be in the third row, second column. So if we add 3 plus 2, we will have negative 1 to the power 3 plus 2. That will give me negative 1 to the power 5, and that is equal to negative 1. So that is why we use that negative sign. But as long as you remember that you always start here with a positive sign, and then you just keep alternating your signs. So negative, or positive, negative, and then positive, you will be okay. So that's what they mean here by the minus sign precedes the second term. Now the second order determinant is obtained, as you already know, by multiplying the elements that would be in the main diagonal and then subtracting the product of the elements across the other diagonal. Now, how do we decide where those 2 by 2 determinants come from? Well, what you're going to do is simply just cross out, if you're using a sub 1, this element here, you're going to cross out the first row and the first column. And then from there, you will take this 2 by 2 determinant, which is what you see here. Now, if you decide to use as your numerical factor a sub 2, what we have here, then you will cross out the column where a sub 2 is located at and the row where a sub 2 is located at. And so your elements for your 2 by 2 matrix will come from here and here, and that's what you see here. And lastly, if you decide to use a sub 3 as your next numerical factor, like we see here, then you cross out the column where a sub 3 is located at and the row where a sub 3 is located at. And then your 2 by 2 matrix will come from here. And that's what you see listed here. So let's go ahead and get started with the examples. So we're going to find here a determinant of the following matrix. Example 3, evaluate the determinant of the following matrix. Now, in this case, instead of using the numerical factors as my coming from my first column, what I'm going to do is use the numerical factors coming from my first row. And the reason for that is that I have a 0 here, so that's going to save me some work. So let's get started. My first numerical factor is going to have a positive sign, my second numerical factor negative, and the third one positive. So in this case, I will have positive 4 times the determinant, and remember, we are crossing the column that contains 4 and the row that contains 4. So the numbers that will go here will be 3, 4, 8, and 1. Next, based on the signs, I need to use a negative sign. So this will be minus. And now this will be my next numerical factor. And for my 2 by 2 determinant, I need to cross out the column where 1 is at and the row where 1 is located at. So the numbers that will go inside my 2 by 2 determinant will be negative 9, 4, negative 3, and 1. Next, I will use 0 as my next numerical factor, so plus 0, and then my 2 by 2 determinant will come from here, crossing out that row and that column where 0 is located at, and then I will use the numbers that I have here. So negative 9, negative 3, 3, and 8. And so what I will do here, this is pretty simple. We take the determinant of the 2 by 2, so we do that by multiplying 3 times 1, that is 3, and then we subtract the product of 8 times 4, which is 32. Next, we have a negative 1, and then we take the determinant here, so we multiply negative 9 times 1, so that's negative 9, and then negative 3 times 4. But remember, the formula comes with a negative, so here we will have minus negative 12. Now here I do have a 0, I will just demonstrate what will happen once. So negative 9 times 8 is negative 72, and minus the product of negative 3 times 3, which is negative 9. Next we have 4 times negative 29 minus 1 times negative 9 plus 12, because we have negative times negative. And then we have plus 0 times negative 72 plus 9. Next we have 4 times negative 29, which is negative 116. And then here we have negative 1 times negative 9 plus 12 is 3. Now here, negative 72 plus 9 is equal to negative 63. But I don't even need to bother doing this anymore, because when I multiply by 0, I'm just going to get 0. So that will be equal to 0. So just to finish this, we will have negative 116 plus 3. So that will, I'm sorry, minus 3. Because we have negative 1 times 3. So that will be negative 116 minus 3. And that will equal to negative 190. Now, I'm going to solve example 4, which is the same thing. We're going to evaluate. And I want you to notice how in this example it will be more convenient to use our third column as our numerical factors, because we have a 0 and a second 0. So that's going to save us a lot of work. Now, to know how our signs will be, we could follow this. We start with positive, negative, positive. And now I'm going to go down the third column. So if we have a positive sign here, the next one must be negative and then positive. So my first numerical factor, as I already explained, will be 0 for convenience. And just so you know, we cross out that column and that row, and we will have here negative 2, negative 3, 1, and 4. Our next numerical factor will be preceded by a negative sign, of course, by following this. And it will also be a 0. And now we cross that column and that row. So our numbers inside the 2 by 2 determinant will be 9 and 5, 1 and 4. The next one will have a positive sign, our numerical factor. The numerical factor will be a 2. Well, keep in mind that I selected that column. And my 2 by 2 determinant will come from here. We cross out that row and that column where the 2 is located at. So the numbers will come from here. 9, 5, negative 2, and negative 3. Now what I need to do is we will have a 0. Here we could maybe just demonstrate one more time. Negative 2 times 4 is negative 8. And then we will have a negative times the product of 1 times negative 3. So that will be minus 3. Next we will have minus 0 times the product of 9 times 4, which is 36, minus the product of 1 times 5, which is 5. Then we have plus 2 times the product of 9 times negative 3, which is negative 27, and then minus the product of negative 2 times 5, which is negative 10. Now, I'm not really going to bother finishing this product because they're going to be multiplied by 0, so they will end up being 0. Same with this one here. And remember, that was the whole reason why I selected my third column as my numerical factors. Now here, I do have to multiply that. So I will have positive 2 times negative 27 plus 10. Plus 10 because we have negative times a negative. So this will become 2 times negative 17, which is equal to negative 34. And so this number here, remember, the determinant is just one real number. So that will be the solution for that example.